Okay, here we have a related rates problem about two bicycles. Two people on a bicycle are at the same place. One of the bicycles starts riding directly north at a rate of 8 meters per second. 5 seconds after the first biker starts riding north, the second starts riding directly east at a rate of 5 meters per second. At what rate is the distance between the two riders increasing 20 seconds after the second person started riding? Okay, well, first of all, you need to just draw a little diagram here of what's going on. You have one biker going that direction, which is north. You have another biker going east, so I'm going to do this here. Okay, now, then I can actually put some values there, like the one going north is going 8 meters per second. So that's why I'm writing it there. But the bottom one, I have 5 meters per second, so I'm going to write 5 meters per second. Okay. Now, it says something else. It says about 5 seconds after the first biker started riding north, the second one started. So we gotta give him some credit for already traveling a certain distance, and the distance is going to be the rate times time, which is 8 meters per second times 5 seconds, which is 40. So that's going to be equal to 40 meters. 40 meters is something that he's already traveled. So that is from here to there. Okay. So now, let's read the rest of the problem. It says, at what rate is the distance between the two riders increasing 20 seconds after the second person started riding? Okay, well, they're talking about the actual hypotenuse of this scenario here. So the equation that brings it together is the Pythagorean theorem. So I'm going to go ahead and write the Pythagorean theorem down here. C squared is equal to A squared plus B squared. Okay. Now, they want to know 20 seconds into the bicycle ride after the second person has started. So let me go back and plug in some information here. So if I multiply 5 times 20, that's going to be 100. And we'll talk about what this is going to be in a little bit. And then if I multiply 8 times 20, that's going to be 160. And it's going to be 160 meters for both of them, right? Because it's rate times time. And the times cancel out, so my answer is in meters. Okay? So now, if I use the Pythagorean theorem to relate these values, I can call this A. Actually, what can I call A? A would be something different than this. It would be 160 plus 40. So that's 200. Okay? Now I'm going to highlight that so we can see it better. That's your A there. Now, what about my B? Well, this is my B here. B is 50 times 20, which is 100. So I'll highlight that too. Now, what you need to understand is we're talking about at what rate, and then they gave us rates as well. So we're trying to find out the rate of this side. Well, we can find the length of that side, which is not the rate, but would we need to know it? Well, if I take the implicit differentiation of this equation here that brings all this information together, I'm going to actually get rates in there, okay? Because you got to remember that whenever we take the derivative, that exposes rates. That's talking about rates. So 2c prime is equal to 2a prime, and then plus 2b prime. Okay? So What do we know C prime? That's what they're looking for. At what rate is the distance between the two riders increasing? So they're looking for C prime. That's what we're looking for. But can we figure out what C is? Because we need it. If we want to find out what C prime is, I need to know C. I know A. I know B. I know B prime. Do I know B prime? Do I know A prime? So, yes, we do. Look, this one is my rate of this side, so that's my B prime. This is my rate of my north travel, which is 8 meters. I know that. So I do know the primes. So all I'm lacking is your C and your C prime. So I can figure this out, and that's going to help me find C prime. So let's see, how do I figure the C prime? C, by using the Pythagorean theorem, and I'm going to enter 200 squared plus 100 squared. Take the square root, and that's going to end up being 200 squared plus 100 squared. That's going to be 50,000. So this square root of 50,000 is what I'm looking for. So 50, 1, 2, 3. That is going to end up being 2 to 3.661 meters. That's the result of this. Okay? So now, all this information here is going to help me. Okay? I know my C, my A, and my B. And I know the rates of 2 of them out of 3. And that's how I'm going to be able to find the rate that I'm missing. So I'm looking at this one over here, and I'm going to plug in 2 parentheses. C is 2 to 3.61. C prime, I don't know. That's what I'm trying to figure out. 2 times A. A is what? 200. So you just got to make sure that you plug everything in right. A prime is what? 8. 2. B is 100. And then B prime is 5. Okay? Then I multiply. This is going to become 447. Point 21. This is going to become 3,200. And this is going to become 1,000. So that's going to be 4,200. We want to solve for C prime, so we divide by 447.21. So C prime is 9.39, and it's going to be meters per second. That is the rate that I'm looking for. At what rate is the distance between 2 riders increasing 20 seconds after the second person started riding? 9.39 meters per second is that rate.